Alright guys, so today we're day 2 of the ellipse. How do we know that the conic we are dealing with is an ellipse? What do we look for? Well, just like a circle, both of those variables are squared. So we have an x being squared and a y being squared. So both of our variables are squared. Just like the circle, it is a sum. So the x is being squared, the y is being squared, and it's a sum. Okay? Now, this is where it differs from a circle. With an ellipse, you have different coefficients. Different coefficients. So pretty soon we're going to have all of our conics mixed up. And you'll have to be able to differentiate between them. So this is what you're going to be asking yourself in your head. What do I see? Are both variables squared? Well, if they are, that eliminates the parabola. Is it a sum? If it is, that eliminates the hyperbola. And then you have to see, do they have the same coefficient? Circle, different coefficients, ellipse. Yes?
So if it's subtraction, that's a hyperbola?
Yes, ma'am. Yes, ma'am. Okay, so, now, yesterday, every single one we did, and this shows us that in standard form, an ellipse would equal 1. So whenever we get an ellipse, and I know this is an ellipse, because it's squared, squared, sum, different coefficients. I know it's an ellipse because it checks off every single one of these. But it's not in standard form for an ellipse, because in standard form it must equal 1. So do you guys have any ideas about how we can get this to equal 1?
Divide by 4, divide by 3.
Divide by...
3, then divide by 4.
Which is like divided by 12.
Divide by 12.
Yeah. So what we would do is whatever this number is, we would divide every term by that. Okay? So 12 goes into 12 one time, so that turns into 1. 4 goes into 12 3 times, and 3 goes into 12 4 times. So we're left with x squared over 4 plus y squared over 3 equals 1. And now we're in standard form. More than likely, I would not ask you to graph this one. The center's easy. It's 0, 0. My horizontal distance is not bad. I would move 2 units in either direction. But my vertical distance would be about 1.71, which if I ask you to graph it, I probably will give you one where we have positive integer moves. Okay, so you try number 2. Okay, so in this one we're just dividing by 36, dividing by 36, dividing by 36. And when we do, you'll say 9 goes into 36 4 times, 4 goes into 36 9 times, and 36 goes into 36 1 time. So my equation is x squared over 4 plus y squared over 9 equals 1. Okay, how is this ellipse elongated? Is its major axis horizontal or vertical?
Yeah.
Vertical.
Vertical. And we can tell that because the larger number is under the y. Okay, now I can tell this equation represents an ellipse, but there's no way I could graph it right now because it's not in the right form. I know it is because the x is squared and the y is squared. It's a sum. And they have different coefficients. So I know it's an ellipse, but it's not in the right form, and you're right. We must complete the square. So to complete the square, our steps were to group the x's, group the y's, and move the constant to the other side. So step 1 is just like completing the square for a circle. But if you remember from completing a square for a parabola, whenever our squared term has a coefficient, that coefficient must be factored out. So we would have to factor out the 9 from all the x values. Whatever that leading coefficient is has to be factored out of all the x values. So now this is what we have. Okay, the leading coefficient for your y has to be factored out of all of the y values. So it has to be factored out of the 4y squared and the 8y.
Alright, let's get it sticky.
I need to keep paying attention.
Okay, so now we have it where we can complete the square. So we have to factor out that coefficient first. Then we take half of negative 2 is negative 1, and square it. What is negative 1 squared? Positive 1. All right, now let's pause for a moment. I just added a 1 here.
Do it on the other side.
But what value did I add to this left side? 9. Because there's a 9 right here. So to keep it balanced, I can't add a 1 there. I have to add 9. That's the only way to keep it balanced.
So is it going to be plus 4?
Good, good. All right, so what do I add here?
A negative 4, or 1.
A 1. And I add a positive 4 here. Because I added a value of 4 to the left side. To keep this equation balanced, I have to add the same amount to the right side. Okay, so now we're going to take these perfect square trinomials that we just created by completing the square to write them as binomial squares. And 23 plus 13 is 36. So how would this trinomial factor? X minus 1. Very good. And then this one would be y plus 1.
Actually, it's very easy.
Okay. Now, one less step. It has to equal 1. So we divide each.
Oh, it has to equal 1?
It must equal 1.
Wait, why is that 1 there? And
This
then
better be like some sort of bonus
9x minus 1.
When is it only with
Like graph.
the ellipses?
Right in here is always half of this.
Oh, okay. Thank you.
Okay, so now 9 goes into 36 4 times. Guys, if you have questions, can you raise your hand? Because there's lots of talking at the same time. Yes, ma'am.
When should it have to equal 1? Always?
In standard form, an ellipse always
Okay,
equals
only
1.
in standard form.
Okay, so 4 goes into 36 9 times, and 36 goes into 36 1 time. So what we have is x minus 1 squared over 4 plus y plus 1 squared over 9 equals 1. Okay, now that would be a pretty one to actually graph. Because left and right we move 2, up and down we move 3. The center is really easy to find. It's 1, negative 1. C would be the square root of 5. All this stuff is pretty easy. So, alright, number 3. We're going to do the same process. Not number 3, number 4. Same process on number 4. So, we group our x's. We group our y's. We move our constant. If there is a coefficient, it must be factored out before we can complete the square. So for the x's, we're factoring out a 3. For the y's, we're factoring out a 5. Okay, I'll give you a moment to catch up.
Oh, boy.
Oh my, this one is.
Okay, so now we take half the middle term, which is -2, square it, add 4, but over here, it's 3 times 4 to keep it balanced. Half of 6 is 3, 3 squared is 9, but over here, it's 5 times 9, which is 45 to keep the equation balanced. So this becomes 3 times x minus 2 squared, and 5 times y plus 3 squared equals 15.
Yes, it is.
And our last step is to divide by 15. So what we get? X minus 2
Over
over 5 plus y plus 3
over 3.
over 3 equals 1. Now, you may have noticed that a lot of times these coefficients just kind of swap. And a lot of times they do, but not every time. Okay? So they're not always just going to swap. So be careful with
When
that.
you're dividing 15 by 3, did you include 15 divided by 3, parentheses, x, and all that, or you would just do it by the code?
Because this is a product, I can cancel this with this. Because this is a product, this can go into that 3 times and we're
It's
good.
always going to be like that?
If we write it as a product, yeah.
Okay.
Okay, so you have 5 and 6 down here. I would like you to try these for homework and check my key online.
Wait, what was number?
That's all?
Okay?
That's
all?
all?
Nope.
There's a batch.
Okay, so
Do that.
I thought,
I'm ink. I got excited because I can.
I don't believe you. All right, now this doesn't give us an equation, but it tells us to take the information we are given and come up with it. Could we write an equation? Yes. Let's do it. So for each one of these, you have been given enough information to write the equation for an ellipse. All right, now I'll tell you what. I cannot do any of these without drawing a picture. I am an extremely visual learner. If I don't see it, I have no shot. So for every single one of these, the first thing I will do is sketch it. This says the major axis endpoints are this and this. So I'm going to real quick, right over here, sketch a terrible looking coordinate plane. And I'm going to put the endpoints of my major axis right here and right here. Okay, the neat thing about the center of an ellipse. The center of the ellipse is located at the intersection of the major and minor axis. It is located at the midpoint of the major axis, the midpoint of the minor axis. It is also directly in between the two foci. So if I give you any of those, the endpoints of the major, the endpoints of the minor, or the two foci, the center is halfway between. Isn't that midpoint? Okay, I don't even need that formula right now because I can tell it's right there. I don't even have to use the formula. I can tell, given this information, that the center is at the point 0, 0. So I have enough information to get a good start on my equation.
Yeah, x squared.
Yep. Okay, now, the only other two things I need are A and B. A is the distance from the center to an endpoint of the major. It's 5. So I can tell A is 5. So since A squared goes right here, 25 goes there. Okay? The minor axis has a length of 4. So that tells me I would go up 2 and down 2 is 2. So B squared is 4. Done.
That was easy.
Yep. Okay, now this one, instead of giving us major, gave us minor. But it's enough. It's all we needed. Okay, so we've got one at negative 12, 0, and one at positive 12, 0. This is the endpoint of our minor. So we know B is 12. We already know that. Now, the center has to be halfway, so the center, once again, is at 0, 0. So I can go ahead and start. X squared plus y squared equals 1. And guys, the horizontal distance is 12 units in either direction. So under x, I'm going to put 12 squared, which is 144. Because remember, our formula is like this. X minus h squared over, it's either a or b. It's our horizontal distance squared plus y minus k squared over our vertical distance from the center squared equals 1. Now, I just have to find that vertical distance. But it tells me the major axis has a length of 26. So half of that is 13. I'm going 13. So 13 squared is
169.
169. Done. Okay, the next one. Just get shifted slightly off of the origin. The center is not at the origin. So let's sketch it. Okay, major axis endpoints at 1, negative 4 and 1, 8. So this is 1, negative 4 and 1, 8. How long is that? 12 units. 12 units long. The length of the major axis is 12. What's half of that? 6. So if I came down 6 from this one or up 6 from that one, that takes me to the center. What are the coordinates of the center? 1, 2. 1, 2. Okay, so now I can start. X minus 1 squared plus y minus 2 squared equals 1. Now I've got to find the horizontal distance from the center squared and the vertical distance from the center squared. I can already see the vertical. This distance is 6. 6 squared is 36. Okay? This one has a minor axis with a length of 8, which means I go how far in either direction? 4. So B is 4. So 4 squared is 16. Done. Okay? This was 4. B is 4. So 4 squared is 16. Okay. You try number 10.
I'm all out. I'm not gonna lie. I need to fill up.
Just be quiet then.
So, I know. No, I pulled it out and trying to use the calculator.
Uh-oh.
Did you sketch it?
Okay, so that's the endpoints of the major. So we're halfway in between negative 3 and 7. That's 7 units, and 3 more units is how many? 10. So halfway is 5. So we came down 5 from 7. Okay, so first of all, you have to tell me what that center is. We just said you come down 5 from here. So what's that center? So it's going to be negative 2, 2 is 5. That's how we know what is in here. It is always x minus the x value. Plus y
minus 1. And the center square. This is the horizontal distance equals the vertical square. It always equals 1.
This one is right.
There.
Yeah, because you go up
Bro,
and down
somebody is
5,
actually about
so
to
the
get
up
hit.
and down
Like,
always go running 5.
Okay, sketching.
Wait. He said country.
10.
Okay, so you're right. If they're 10 units apart, 3 and 7 is 10. So the center has to be halfway, so it's 5 units down. The center is 5 units down from that, which puts it at -2, 2. So we're halfway there. It's x minus -2, which makes a plus. Y minus 2 equals 1. All right, now we need the horizontal distance squared and the vertical distance squared. We know the vertical distance. It's 5. So 5 squared is 25. The vertical distance always goes under the y. Now, the horizontal distance, if the minor axis has a length of 4, we're going 2 units in either direction. So 2 squared is 4. And we're done. Yep.
Yeah.
Okay.
Yeah.
Number 11. Number 11 does not give us the major endpoints or minor endpoints. It gives us the foci. But the center is the midpoint of the segment that connects the foci. It's halfway in between. So even without drawing, you guys can tell the center is at 0, 0. But if you needed a sketch, sketch it. The center has to be at 0, 0. Now, the thing we have to remember, the foci always lie on the major axis. They always lie on the major axis. So if the major axis has a length of 10, we know we come out here 5 and we go out here 5 to get those endpoints, because it has to be on the same axis as the foci. The foci are on the major axis. So we know A is 5. So now we know x squared plus y squared equals 1. We know A is 5, and it's horizontal this time, guys. So the 25 goes under the x squared. Okay, now we have to find B. The formula is C equals the square root of A squared minus B squared. Or you can go back to C squared equals A squared minus B squared if we squared both sides. So we know C is 2. We know A squared is 25. So B squared is 21. Because 25 minus 21 is 4. So under the y is where the 21 goes, because this is always B squared. B squared.
I'm done with this.
Yep. All right, you try number 12.
I got it. You good? I'm mortally just.
Oh, no.
That was more circular-ish than the other ones.
Oh yeah, yeah. Okay, we don't have time to get to 13 and 14. So I want you to finish up the 4 we didn't do for homework. And I'll go ahead and post those solutions online so you'll have it to look at. Now, tomorrow you have practice. Nothing new. Practice over what we've learned. I'm going to go ahead and give you one of the worksheets, and then tomorrow our sub will give you the second worksheet. Actually, no, we don't